Now, in this video, we're going to take up a problem on projections of lines. It reads as a line capital AB 80 mm long has its end capital A 20 mm above HP and 30 mm in front of VP. It is inclined at 30 degrees to HP and 45 degrees to VP. Draw the projections of the line and find its apparent length and apparent inclination. When you try to analyze this problem, we can see the problem which can be analyzed in 3 dimensions. How I can look at it? If I see a line capital AB 80 mm long has its end A 20 mm above HP. When we are talking about 20 mm above HP, here you can see it is 20 mm above HP. How do I look for above HP? When you look from the front view, you can see the distance above HP. So this is front view. When you look from the front view, you can see the distance above HP. That image falls on VP. You can see that projection. It is 20 mm above HP, which becomes A dash. And 30 mm in front of VP. In front of VP, when you look from the top view, you can see from the top view, you can see the distance in front of VP. That image falls on HP here. You can see A, which is 30 mm in front of VP. It is inclined at 30 degrees to HP. Which is the line which is inclined? A line capital AB. A line capital AB means what? According from the introduction of my introduction of lines, when we took up those, when you go through the videos of that, line capital AB means it is always the true length of the line. If I say the line is true length of the line, obviously that line has to be parallel. So that should be the condition. So parallel to what? Parallel to either it can be VP or it can be HP. In the sense that the true length of the line will always remains same in both in the front view and as well as in the top view. It says it is inclined. So that is the true length of the line is inclined at 30 degrees to HP. So where you can see that inclination? I can see the inclination in the vertical plane. You can see that the line which is inclined at 30 degrees to HP. It is the true length of the line. So that is the reason why true length means what? Since it is the true length in the vertical plane, obviously that line should be parallel to VP. So parallel to VP means what? It is 30 mm in front of VP. So obviously capital A is 30 mm in front of VP and capital B1 is also 30 mm in front of VP. So this is the actual length of this line, which is the true length of the line, which is capital AB1. And it is also inclined at 45 degrees to VP. So which is that? It is the true length of the line. So means what? True length of the line means it is 45 degrees to VP. So that line should be parallel to VP. Parallel to VP means what? Where you can see when parallel to VP means and it should be parallel to HP. Now here parallel to 45 degrees to VP. So that means the inclination you can see in the horizontal plane. You can see that that line is inclined at 45 degrees to VP. So that is capital AB2. So that is the length of the line. So it is when you project it, you will going to get that view here, that is capital AB2. When it is projected down, you can see that it will be small AB2, which will going to be the true length of the line. So this is how we will be able to, that means capital AB2 and capital AB1 we got. Once you get the capital AB2 and capital AB1, so that means that you have the locus line here in the front view and the locus line in the top view. So that is what we have written here. When you see that XY line and VP and HP, you can see here 20 mm above HP and 30 mm in front of VP. You will going to get the line which is A dash because the image is on the vertical plane, and 30 mm in front of VP, which is small a because it is the top view. It is Since it is in front of VP, it will be on HP. And he says the true length of the line, which is 30 degrees to HP. So we can take that this is capital AB1, that is A dash B1 dash is the one which is going to be the true length of the line which is making inclination of 30 degrees. Which is that line? That line what we are talking about is this line which is projected, which will going to get A dash B1 dash. So we have the locus of B, so we have the locus of B. What is the locus of B means? The locus of B means where the front view of the line will going to end, or it will going to touch. Similarly, you can see here 80 mm of 45 degrees. So you are going to get AB2, so which is small AB2, that is this line. When you are keeping it in space, it will be capital AB2, which is because it is the true length in HP. Obviously, that line should be parallel to HP. So 20 mm above HP. So A dash B2 dash is the line which is 20 mm above HP. So here this is the true length in the vertical plane, because AB1, you can see that small AB1. So that AB1 is this, which is the top view, where A is in front of VP by 30 mm and B1 should also be in front of 30 mm. That is the reason why you are getting this line is parallel to VP. Now once you do that, now what we want to find out? We want to find out the apparent length, and he says find its apparent length and apparent inclination. So as we see here, we have the locus of B in the front view and you have the locus of B in the top view. So what does the locus of B means? The locus of B means where the front view point will going to end and where the top view point will going to come and lie. So when you are doing that, see, you can see here what actually you are going to have. You have A dash B1 dash and we have A B2, and we have the locus of B and we have the locus of B in the front view. So now actually what we have now is only this line and this line and this line, we have the locus. Now we need to write the top view. Suppose if you are considering this as the front view line. So this is the true length of this line, which is 80 mm. So as we know that the corresponding front view, so that means you come up to this, you can see here, you have this line which is A dash B1 dash, which is the locus of B in the front view. We have AB2, which is the locus of B in the top view. As we know that it is the true length of the line, he says that it is given in the problem, the true length of the line is 80 mm inclined at 30 degrees to HP. So as we know that this is the true length of the line in the front view, obviously its corresponding top view should be parallel to XY. So you are writing the top view for this. When you write a top view for this, you will going to get AB1. Anyhow, A is fixed. A is above HP by 20 mm and A is 30 mm in front of VP. So obviously that B1 dash should be in front of VP by 30 mm. Then only this line will be in true length. So that means the top view of this A dash B1 dash should be parallel to XY line. Therefore, you are projecting this till here. So you got AB1. But in the top view, the line is inclined at 45 degrees to VP. So therefore, you are getting the locus of B in the top view. That means the top view of the line will not be here, but it should be B1 should be, A is already fixed, so A will not going to be rotated. But B1 is the one which is in front of VP by 30 mm now is not actually equal to 30 mm, but instead it should be on the locus of B in the top view. So as we see here, you can see that AB1 is the one which is rotated in space such that B1 will going to come and touches the locus of B in the top view. So you can see that B1 is touching the locus of B in the top view where it cuts the locus of B. So how with A center taking the radius of AB1, you rotate that such that it will going to come and cuts this point here. So you will going to get the top view. So this is the inclination which is made by the top view with respect to VP. So therefore you have got beta. So when you are actually showing in the 3D analysis, you can see capital AB is the line which is in space. As you rotate in space with fixing the point A, that B1 is rotated till it comes and touches the B. So as we rotate, what happens in the space? Naturally, the image is also being get rotated from AB1 such that it will going to come and touches the locus of B in the top view. And this point will going to become B, and you join AB, so that will going to be the top view. The inclination made by this with respect to VP is beta. So we will going to find that. Similarly, what we wanted to do now, I wanted to do the front view. To get the front view, you do opposite. So what does it mean? What is that opposite? What you are trying to do now? So here we will going to get the true length. We are going to take the true length in the horizontal plane, which is that capital AB2. Now you are taking that AB2 here, which is the true length of the line. So here you know that the true length in HP means what? It should be parallel to HP. You can see that this is parallel to HP. When you are looking from the front view, the image will going to fall on the vertical plane, which is A dash B2 dash. How to analyze that now? As we know that it is the true length in the horizontal plane, obviously that line should be parallel to HP. So A dash is above HP by 20 mm. Therefore, B2 dash should also be above HP by 20 mm. So that is what we have taken here. As it is in space, A dash B2 dash is the one which is the top with the front view, which is parallel to XY line in the front view. So therefore, you project this B2 onto the vertical plane such that both A dash and B2 dash is above HP by 20 mm. That is what we have shown. Here is also 20 and here is also 20. So then what I should do now? I must, because the locus of B in the front view is here, that means the top view, the front view point of B2 dash will not be above HP by 20 mm. Instead, it should be above HP by this distance. So in order to do that, with A dash as center, taking the radius of A dash B2 dash, you rotate such that it will going to touches the locus of B in the front view, and you mark this point as B dash. When you are doing it in space, what we will going to do is you take the true length in the top view, which is capital AB2, you rotate it in space such that B2 will going to come and touches the locus of B in the front view. So that means this side, it will tilt to this side, this line is being get rotated. So as it touches this locus of B in space, so correspondingly what happens to the image? The image is also being get rotated from A dash B2 dash. It is rotated till it touches the locus of B in the front view, and you mark that point as B dash and join A dash B dash. So you are getting the A dash B dash. So alpha is the inclination, which is the apparent inclination made by the front view line with respect to HP. So this is how you will be able to analyze it. When you want to combine these two, so what happens, we are going to see. We will come to this. Now how to draw this projection on the sketchbook. So to do that, first we will going to draw the XY line, and you mark XY and VP and HP. Next what we need to do. So first we are going to take NDA is above HP by 20 mm and 30 mm in front of VP. So from XY line, you measure a distance of 20 mm and draw a horizontal thin line. Similarly, from XY line, you measure 30 mm below XY line because it is in front of VP is seen in HP. So from here, you measure 30 mm and draw a horizontal line, thin line. Then take any point on that take any point and mark that point as A dash, and from here you draw a vertical thin projector to cut this horizontal line, and you mark this point as small a. Then by using the protractor, you measure an angle of 30 degree with respect to the horizontal, then draw an inclined line. Similarly with A center, taking the with respect to the horizontal, you measure 45 degree below this horizontal line and draw a inclined line. By using the compass, you measure a distance of 80 with A dash center, cut an arc on this 30 degree line. Similarly with A center, taking the radius of 80 mm, cut an arc on that 45-degree line, and you mark this point as B1 dash and you mark this point as B2. Then draw a dashed line both in the top view and as well as in the front view, and mark this as the locus of B in the front view, and you mark this as the locus of B in the top view, and join A and B2 with little bit thicker than the XY line. Similarly, A dash and join B1 dash with little bit thicker than the XY line, and you mark this point as capital A and capital B, and you mark this as capital A and capital B in the top view. That is because he says line capital AB is 80 mm long. So that means he says that it is the true length of the line. So once you get this, now we need to write the top view and front view. So to do that, so as we know that since it is the true length of this line in the front view, obviously that line should be parallel to XY. But we don't have the top view for this A dash B1 dash. But we have the top view for A, which is small a, which is already given in the problem. So as we have drawn a horizontal line, since it is the parallel to VP, so that means in the horizontal plane you should get a horizontal line. So then only this line will be in true line. This has been taught when you are referring our previous video, the line which is inclined to HP and parallel to VP. As we know that the front view line is in true length, correspondingly its top view should be parallel to XY. Apply that rule here. So as we know that NDA is in front of VP by 30 mm, NB should also be in front of VP by 30 mm, then only that line is parallel to XY. So therefore, you project from B1 dash, draw a vertical projector to the top view such that it touches this 30 mm line, so that it will be small b1. Due to the presence of the true length in the top view, which is B2 is in front of VP by this distance with A as center, by using the compass with A as center, taking the radius of AB1, you draw an arc such that it will going to cut the locus of B in the top view, and you mark that point as B, and then join A and B with a dark line and mark this as beta, and you mark this as angle 45, and you mark this as angle 30 degrees, and you mark this as 20 mm, and you mark this as 30 mm. And similarly, what you should do now, I want to find out the front view. To find out the front view, I should take the true length in the top view. So which is the line which is the true length in the top view? You have the line capital A and capital B, which is nothing but small a B2, which is already given in the problem. As we know that this is the line is in the true length in the vertical plane. True length, that means it is inclined to VP and parallel to HP. So as we know that it is the true length in the vertical plane, true length in VP, so true length in the horizontal plane, that means that the line should be parallel to HP. So as we know that A dash is above HP by 20 mm, so B2 dash should also be above HP by 20 mm. Then only the line is parallel to XY line in the front view. As we know that it is the top view is in true length, then its corresponding front view should be parallel to XY. So A is above HP by 20 mm, so B2 dash should also be above HP by 20 mm. So therefore, from B2, you draw a vertical projector such that it will going to cut the 20 mm line. So you mark this point as B2 dash. Then as we know that the front view line is at a distance of this distance, that the B1, the locus of B is in above HP by this distance, it is not by 20 mm, with A dash as center, taking the radius of A dash B2 dash, by using the compass, you draw an arc such that it will going to cut the locus of B in the front view, and you mark that point as B dash, and join A dash B dash with a dark line, and you mark this as angle alpha. Then by using the scale, you measure the apparent length of the front view and also the top view. As we see A dash B dash, which is 56.57 when you are doing it in computer, but actually when you are doing it in manual, you will going to get it as 57 mm, and you mark them as 57 mm. And similarly, by using the scale, you measure the distance of AB, which is the top view, which is taking as 69.28 when you are doing it in CAD, but when you are doing it in manual, it will be 69 mm. By using the protractor, you measure the angle of A dash B dash with respect to the horizontal, which is alpha, which is the apparent inclination with respect to HP. So alpha will be exactly equal to 45 degrees, and by using the protractor with A as center with respect to the horizontal, you measure this particular angle, by taking below this below this horizontal line, and which will be equal to beta, which is 54.74 degree when you are doing it in manual. When you are doing it in computer, this angle will be equal to 55 degrees. So this is how you will be able to draw the same problem by using the sketchbook. So this video will going to be able to display, or you will be able to make you to understand that how I can analyze the problem in three-dimensional analysis of how it will going to look like, and here how we are able to do it in manual. So to brush up here, you will be able to see this has been the combination, but here I am taking individually how I can do it, how able to find the top view here in this case, and in the next slide you can see how I can be able to get the front view. So this is how you will be able to analyze this step by step. So this video will make you to understand how the line which is inclined to both the planes, how we can be able to find out the apparent length and the apparent inclination for this particular problem. Thank you.